Okay, more of the finicky bits. So Mara is going to shave down the tenons to fit nice and snugly in the mortise without a whole lot of friction. Since the mortises were hand cut, these are machine cut. She snuck up on them, like she said, and now she's going to clean these surfaces up so it fits better. Now we will be using a hand tool. Amazing that hand tool. This is a shoulder plane that I couldn't remember the name of earlier in this video, and it's the LaBelle Veritas. It's one of the nicer planes that I have. And Mara's going to just take it and just shave that surface like so. See that? Mm-hmm. And then make them fit into these two slots here. And on that note, I'll leave it to Mara to do.
Was this the left or the right?
That's that one.
That one. Okay.
Okay.
Cool.
All right. So you go ahead and do that, and I'll be back. Oh, this one here? Oh, I see, yeah. Oh, you mean the bottom of it?
Yeah.
Okay, cool.
No, I mean just in general.
Ah, okay.
Yeah.
See, this is the kind of things you run across when you're doing mortise and tenon joints, and don't bang it. Because you bang it, we can't hear. They can't hear. So Mara's, as she just said, she has to clean up a hole. It's not quite as it should be. Learning curve. Yes, Mara is learning a lot of new stuff, and she'll take over the shop, and I'll never see you again. Anyhow, with that note, you go ahead and clean this out, and
Yep.
we'll catch up with you later.
Cool. I've got a ways to go on that.
A wise woodworker once said to me that you know you're a pro when you no longer have to ask how. Now, what he meant by that was you don't know everything, you never will, but you have the skill set and the knowledge to work around the problem or fix the problem or the mistake that you made. That's what he's referring to. By the way, it was Charles Neal, the same guy that I bought the taper jig from. Now, we've run into a little issue. And it's one of those right and left hand kind of things. Mara can go into start with the details, and then we'll zoom in and show you what's going on.
I turned both of these lovely warp beams, and then in fitting the tenons into the mortises in the tables, I found that they are just a smidge too wide. And the reason for that is that we were working both from the plans and from the original Loom, which is just a smidge wider than the Loom in the plans. So if this were going on the original Loom, it would fit perfectly. However, it needs to be about a 1/16 of an inch narrower.
Yeah.
So I need to figure out a way to put this back on the lathe and fix that. And I've been looking into my various options, including turning a cup center so that I can chuck it back up.
Yeah, it just has to run the parting tool a little bit down here. Let's do a close-up and show you what we're talking about.
So here you can see it fits perfectly. It rotates very nicely. And then if we go over to the other Loom, it does not fit. So this was pushing these out and causing them not to fit. And so you can see we just need to give it a tiny bit of a shave. And that should fix it. But to do that, I need to make another part for the lathe.
So Mara came up with a really elegant solution. I'll take pictures of this and shove them up so you can see them. What it is an interpiece that goes between the workpiece and the life center. And it's conical in both directions with a 1/2 inch hole through it. Mara, explain more what's going on here.
Right, so obviously one side sits over the conical shape of the live center, and the dowel part, axle of the cloth beam, warp beam, fits into the other side. And then Kevin did the machinist's trick of tapping it into place because it was spinning just a little bit off center. And we've also added a steady rest to hold it in place as I'm pushing against it, because I don't need this thing springing off the lathe into my head, which is also why you wear this.
What this does, of course, is it allows us to repair the part, or her to repair the part, without having to put the spur drive in one end and the live center in the other end and poke holes in it. This way it remains as it was, and then she turns off the 1/16 of an inch or so.
Yes. Now I do have it chucked up securely on this end, and that'll mar the sides a little bit, but that'll be inside the upright, so it won't matter too much.
Okay, let's get started.
And there you have it. They fit beautifully and turn well, and they're all sanded back down again, and we're good to go.
What we're doing now is, well, what I'm going to do and then what Mara's going to do, we're drilling 10-degree holes in the back of the plate right here. Front of the plate right here, where this support for the roller back here goes at 10 degrees. Now, I made this jig, if you saw earlier in the video, for drilling the leg holes. Mara went and made a jig specifically for drilling 1/2-inch holes. Now, the way this works is we clamp it up here, drill, move it over, drill, move it over, drill, move it over, and that way we remove 99% or 95% of the stock, and Mara can finish it with the chisels. Now, come in closer and I'll show you exactly what I mean. I know it looks a little messy with these lines, but here's the taper of the back of the front. I keep doing that. Here's the taper of the back of the loom, and this wasty spot here is where I have to drill the holes, and they have to be at 10 degrees. So here's the start line, and here's the finish line. And since the drill is a slight angle this way, we end the finish line here. So basically, I clamp it up like so to the first line, drill a hole, move it over to the next one, drill a hole, move it over to the next one, drill a hole until we hit the finish line. I've got it clamped up on the first line. I'll do a couple, you do a couple, we're good. All right, so I'm going to get the first one. Well, this is the moment of truth to see if I actually got it right. I think I need to use the bigger drill. Voila.
Okay.
You still got more over here to remove.
Yeah, I can do that.
You can do that?
Yeah.
Okay. So let me actually get the bigger drill.
More power.
More power.
Got to do the 10 Allen grunt. But is it a Binford?
It's not a Binford. No, it's not. But this probably just needs a battery change. But it's a 12 volt. This is an 18 volt. Kind of overlapping the previous hole, so hopefully this will work out fine.
Yeah.
Voila.
Woohoo!
Have at it.
Okie dokie.
Super.
Yes.
Clean all the debris off so we can. Yeah, it's on the bottom, it's some chip out.
Yeah, I can deal with that.
See, let's see if the next hole is correct. Yeah, look, see? It's got that overlap.
Cool.
Okay, I'll do this one, you do the next one.
Okay. Oops.
Love these Irwin clamps, by the way.
I think I need one of these at 15 degrees for stools.
Yeah, this one, it seems to be creeping a little bit.
It does.
But you can get by that by fitting the mortise.
Okay.
Fitting the tenon.
Yeah.
So now so that's the finish hole. Mm-hmm. So let's get this one. Yeah, that's okay. That gives it most.
It's manageable.
So now you guys need to see what's going on here. So you see now we've got the holes drilled. That removes most of the material. This is where it was jumping away because we couldn't get it down tight enough. I should have put a blocker on here. That would have fixed that problem. But there's the end here, and there's the end. But the vast majority of the material is gone, so Mara can now do the chopping with the chisel. Mara took those round holes that we drilled and chopped out a nice rectangular 10-degree hole with much gnashing of teeth and messing with chisels and stuff.
And now it fits. So you can see there's a little 10-degree angle there. I've already taken a stick of the correct height and marked where I need to relieve this so that it sits flush. Then when I've done that, I will cut out this part, which is where the roller goes. You can see I've already drilled the hole for the roller and also drilled a hole for a stop dowel here to keep this from splitting, because when Kevin made the one on the Dave Hoffman loom, he found that it tended to split here. So I've preemptively drilled and pegged that. And then it will be tapered down like this. I've done the fiddly bits on this now. I've chamfered the edges all around and sanded and smoothed, and now it fits in here perfectly. I had to cut the angle, and then this will have an axle like this. I need to get some more 1/4-inch rod. I think I'm going to turn a couple buttons to go on either side to cover the ends of the rod.
So I want to make a couple of axles. If you hear some banging in the background, Mara's cutting some mortises again, but there she goes. This axle right here is a 1/4-inch piece of steel. Had a fold at one end and a pin at the other. What Mara wants to do, and I agree, is to have a cap glued on one end and then a 1/4-20 nut in a cap on the other end so we can screw it together, and it looks much prettier than this. It has nice turned caps at either end. So I've cut out 2 pieces of 1/4-inch steel rod, and I'm now going to run a die down on one end to about a 1/4-inch worth of threads, and then from then on I hand them to Mara and she makes the magic with the lathe. So here's the piece that I cut out. It's 4 1/8. I tapered the end to accept the die easier, slightly tapered the other end to go into the wood easier. Now I'm going to take my 1/4-20 die and run it down onto here and cut about a 1/4-inch worth of thread. And so I got to put it in the machinist vise because you need really good grip on it. It's clamped down. I know it moved, but then a little bit of oil. Always lubricate your work when you're cutting with a tap or a die. All right, so die is in place with the feed end facing outward, of course. That's the side of the die that has a label on it. So now start the workpiece just by pressing down and rotating the die, and it'll start cutting into the metal. And it'll draw itself into the work because it's cutting threads. And you come back to relieve the chips out of the cut you just made. So about a 1/4 turn, maybe half a turn around. You knock the chips out. Now, of course, this is mild steel, so it's dying very easily. It's getting the threads pretty easily. Okay, I think that should be enough. Support the tool, and there we have it, about a 1/4-inch of threads. So we got 1/4-20 threads cut on the end of that. They need a little bit of cleanup, but here's a 1/4-inch nut. Screws on there very nicely. Next step is for Mara to do the turning of the buttons. Now we're going to do the heddles. As Mara pointed out in the intro, there are two heddles. They're front and a back. For our purposes here, there's an A and a B. And they're dimensionally the same, but the slots and holes are offset by 3/16 of an inch because these holes, as she said, go through these slots and vice versa. So the first thing I did is I took two drawings that came with her drawing package and measured against this to make sure everything was on the same sheet of paper, so to speak. From that, I developed this AutoCAD drawing. This AutoCAD drawing I saved as a DWG, which I then imported into VCarve. And in VCarve, I developed the toolpaths. And this is what the toolpath drawing looks like. You can see little arrows and stuff where the toolpaths go. Using an 1/8 inch upcut carbide end mill, it's 3 passes for the slots and 1 punch down for each of the holes. But when you're using a CNC machine, it's always good to do a test cut. So I did a test piece to make sure that dimensionally it was correct and everything was in the right place, and it came out fine. I've milled up the parts for A and B for the heddles, 7/16 thick, and these will get the slots and the holes, and then we'll cut everything else by hand. So let's go to the CNC machine and do some robotic woodworking. With the drawings done and the tap files created for our CNC, next step is to get the work chucked up into the CNC. And for those who are not familiar with CNC, we use a spoil board. And a spoil board is wood that goes underneath your workpiece. So if you're punching through your workpiece, you don't hit the aluminum table of your CNC machine. Spoil board because you replace it over time. This one's on its last legs. There's not much left on this one, so I've got to make a new one. And now the blanks that I have cut out, milled and cut out, are marked with the absolute center. I use the center point of the workpiece in the software to index the cutter head of the CNC. Now, the way I do this is I take these 2 pieces of wood that you see here, and I put this piece pretty much in the middle, and then I put it down with a pinner, so this holds the piece side to side, and I've got wooden clamps, wood for in case your cutter runs into a clamp, which it shouldn't if you set it up right. And I clamp the workpiece down with screws and washers to hold it in place. Never use power tool on this because it is in fact MDF, and you can just pull the screw right out of it. So now the workpiece is chucked up onto the spoil board, and I can now start cutting out the heddles for the tape looms. I've got this set so that the slots in the spoil board line up and distance-wise from the edge, pretty much right on the channels in the table for the CNC. So basically, I can clamp it down with these cam clamps that I got from Rockler. Rockler Blue. With the spoil board now installed, now I will index the head. And that means going down. Okay. So the cutter going this way can find the center of the cutter very easily. Quick. Turn the cutter the other way. And it's got to go just a little bit to the left. There it is. So that's centered. Okay, I've got it centered now, so I'm going to zero it out. Okay, so now it knows where 0 is. But now you want to get this cutter indexed right to the top surface of the workpiece. And we have an indexing plate that comes with the CNC machine that allows you to do that. So basically I go to plate, okay. I know I should have the camera down here, you can see this, but and touch the cutter, and yes, it means it wants to know that you're right over the plate. Hit OK, and now it indexes the head, so now it knows exactly where the surface of the workpiece is. OK. Now we install the rest of the stuff. So come back up, put the dust collector system on, like so, plug in the dust collector, and my ears magically appear. So I thought I'd give you a little push see as how this works. So I go USB, tab file B, and next, and then start. Now I'm going to cut the gears. Required a new drawing because the gears we have are the same shape and all around function, but these are 1/2 inch and we need 1/4 inch for the new tape looms. So again, I know I said the last cut was going to be the last laugh for the spoil board. Well, one more. I'm going to cut the gears out of this 1/4 inch piece of maple. So I'll go through the same process I did before, show you the end product when I'm done. And then I swear I'm going to retire this spoil board. 4 gears. Now, they're still in the workpiece because when you're doing things like this, you have to put bridges in to hold the piece in place until it's finished cutting so it doesn't pop out and go across the room. So this will have to be cut out of the stock, and then a little bit of cleanup, and then we've got the gears for for both of the tape looms so you can lock the threads tight.